Hello students, welcome back. In this video, I'm going to solve some questions from hydrocarbons chapter. We'll try to cover as many as subtopics possible by solving the questions. The first question is about the reaction of an alkyne with bromine in water to form a molecule with the formula C4H7BrO. And what is the correct structure of this molecule? So in order to find out this, you need to know the mechanism of the reaction. The reactant given here is 1-butane molecule and it is treated with hypobromous acid. Why did I call this as hypobromous acid? Because when the molecular bromine is taken in water, it's going to form the hypobromous acid. Many students, what they do is they polarize this as H plus O minus Br like this. Okay, this is very much wrong. So how this molecule will get polarized is OH minus and Br plus. These are the ions it's going to form. Why so? Because oxygen is an electronegative element. So it will take the bonding electrons and it will form OH minus and Br plus. Why is this important for us now? Because alkynes are electron rich centers. When they are electron rich center, they will attack the electron deficient. So which is the electron deficient species here? Bromonium ion. This is the electrophile. So the pi electrons which are loosely held between the carbons is given to the Br plus ion. So what happens now? The triple bond will become double bond and the bromine goes to the carbon with more number of hydrogen. Nothing but this is Markovnikov's addition. So what happens here? The bromine is formed. Already there is a hydrogen, you can write that. What happens to this carbon? The positive charges form. So we have hydroxide ion, right? So it will attack this particular carbon. And what we are going to get here? So observe this. So we have bromine and hydrogen here. This is where the OH will attack. How many carbons do we have here? 2. So write down that as it is. And what is this? This is a enol. Are enol stable? No. So they will undergo tautomerization like this. So this we call it as keto-enol tautomerization, isn't it? So what we get here, the ketone, right? The hydrogen will shift from oxygen to carbon. That's why this is also called as 1,3 shift of hydrogen. So this will become CH2Br. And where do we have this? In option D. Therefore, the correct option is D. The next question is based on the preparation of alkenes from alkynes. The given dialkyne molecule, when it is treated with lithium in liquid ammonia, it's forming one major product, that is A. We have to identify that. You might have come across similar reactions. So say for example 2-butane, when it is treated with sodium in liquid ammonia, what do we get? We always get a trans product. So here we are getting trans 2-butene molecule. Why do we get this? Because the first step here is sodium undergoing oxidation and it will give the electrons. So there will be 2 lone pairs of electrons and these are negatively charged, right? Therefore they repel each other. Hence we are going to get the trans product. In the question, lithium is given instead of sodium, but the reaction will remain same. And in fact, lithium is more reactive than sodium. There are two options. Both of them are having diene here. But we need to look at the stereochemistry of the products. What you have to do is check for the positions of the hydrogens. If hydrogens are on the same side, we are going to get it as cis. So this is cis and this is also cis. But we don't get cis product as I told you earlier. It has to be trans because of the lone pair repulsion where the hydrogen will come and attack, isn't it? So let's look for this one. You see the hydrogens are opposite to each other like this. That means what? This is a trans-trans configured. Hence, which is the correct option here? Option B. In this question, you have to arrange the given 3 molecules in the increasing order of their reactivity towards electrophilic substitution reaction. How did I know it's electrophilic substitution reaction, although it is not given here? Because benzene or any other aromatic molecules generally undergo electrophilic substitution reaction easily rather than nucleophilic substitution or addition, etc. Now, How do you know that which molecule will undergo electrophilic substitution easily? If there are electron donating groups. What are electron donating groups? Like methyl, hydroxy, amine. Either they donate the electrons through inductive effect or resonance. By this, the electron density on the benzene ring will increase and the electrophile will attack this benzene ring easily. That's why electron donating group increases the rate of reaction. Now, what about the electron withdrawing group? Electron withdrawing groups like nitro, aldehyde, keto, acid, all these will withdraw electron, making it electron deficit. See, electrophile is already electron deficit, and if the benzene ring is also electron deficit, then the attack would be difficult. So what happens in this case? The rate of the reaction will decrease. So what all electrophilic substitution reactions can be done here? Nitration, sulfonation, chlorination, Friedel-Crafts alkylation, acylation. For all these reactions, the order will be always same. Let's examine these molecules now. See, all of them have esters attached to it. So these are cyclic esters, therefore they are lactones. You have to just check whether the oxygen of the ester is directly attached to benzene or the carboxyl group is attached to the benzene, because if oxygen is directly attached to the benzene, then it donates electrons through plus R effect. That means what? It is increasing the electron density. If the carboxyl group is directly attached, then it withdraws electrons. So minus R. Then what happens to its reactivity? It decreases. Now check the third molecule. There are two oxygens which are directly attached. So both are donating electrons to the benzene ring. So electron density is doubly increased. Hence, this will have higher order of rate of reaction. So where do we have it? In option D. Therefore, the correct option is D. However, let's find out why 1 is the least. Why 1 is the least? Because there are two minus R groups like this. That's why it is the least. What about here? There is one electron donating and one electron withdrawing. Therefore, it is in between. Most of the cases, when the question is tough or lengthier, the options will be easier. So take the advantage of such options and get the right answer. For this question, you have to identify a reaction which is violating Markovnikov's addition. What is Markovnikov's addition? Whenever you have unsymmetrical alkane and when you have an electrophile, right? Like say for example H plus, it goes to the carbon with more number of hydrogens directly attached to it. So here the carbon is attached to two hydrogens. Therefore, the electrophile will go to this carbon so that it is going to form a stable carbocation. So in this case, it is a tertiary carbocation. So this we call it as Markovnikov's addition. Generally, this is how it will happen for the alkene molecules. In some cases, this might be violated. When is it? So that is what we are discussing through this particular question. Look at the first reaction. This is alpha beta unsaturated ether. So according to Markovnikov's addition, the electrophile H plus goes to the carbon here and the carbocation will be formed over here. Is this carbocation stabilized by any way? Yes. The lone pair of electron present on oxygen will donate the electrons and stabilize the carbocation. So you can ask me, see, oxygen is electronegative element, right? So it can withdraw electron and destabilize. Why aren't using that phenomena? No, that is not applicable here because oxygen withdrawing electron is through minus I effect. The electron is donated through plus R effect. And which phenomena predominates always? Resonance predominates inductive effect. Hence, oxygen with the lone pair, it acts as an electron donating group rather than electron withdrawing because resonance predominates over inductive effect. This is quite important and you have to remember this. So because of this, it is obeying Markovnikov's rule. No exception here. Similarly, here also nitrogen, although it is electronegative element, it donates electron to plus R. So very much stable. Similarly, thioether, the sulfur lone pair is also given to the carbon to stabilize the carbocation here. But what about when there is a nitro group? The nitro group can be written like this. You can see that when the carbocation formed here, after this carbon accepts the electrophile like this will not be stabilized by resonance. You can see that the nitro group is electron withdrawing through minus R as well as minus I. So because of this, it will destabilize. Therefore, it will not undergo Markovnikov's addition. In fact, the hydrogen will go here so that the carbocation will be formed here and then the Br minus will attack. So what will be the final product? We can write that now. So there is a CH2 and then CH2Br. We are getting anti-Markovnikov's product because when CH2 is away from the nitro group, right? So then it will be more stable. The carbocation will be more stable when it is away from nitro. That's why this is more recommended here. Hence, which is not obeying Markovnikov's? Option D is not obeying. Therefore, that is the correct answer. A hydrocarbon with the molecular formula C4H8 on reacting with MCPBA, a perbenzoic acid, it gives X. X on reaction with aqueous KOH, that means substitution, not elimination, it forms Y. Y on treatment with concentrated H2SO4 forms 2-methyl propanal. So how to write this? So first you write the propanal. So this is 1, this is 2, 2-methyl propanal. So what is the hydrocarbon C4H8? See, generally when such questions are given, I will write it down like this so that it's very easy to predict the correct answer. Look at this. This is having isopropyl structure. So the reactant must also have a similar structure. And in the first place, you can eliminate this molecule. Obviously, it is a reaction of an alkene, not a cycloalkane. So you can eliminate this. And you can start from this because you can see that there are 2 methyl attached to the carbon. And verify whether all these statements will hold good for the reactant A. So this is isobutene. When isobutene is treated with MCPBA, it's going to form epoxide, a cyclic ether. This cyclic ether is X now, is treated with KOH. So it will undergo nucleophilic substitution. So it attacks the carbon where there is less steric hindrance. So what you are going to get here? A tertiary alcohol and here a primary alcohol. In fact, this is a vicinal diol molecule. And when it is treated with H+, see, the moment you see a diol, remember there is a possibility that it's undergoing pinacol-pinacolone rearrangement because the product formed here is an aldehyde from diol. So you have to keep that in mind. So what is pinacol-pinacolone rearrangement? You see, because it is a tertiary alcohol, it will first undergo dehydration here with H plus and it will form a stable carbocation. What carbocation? A tertiary carbocation like this. Now what should happen? It should get stabilized. How it will get stabilized? By the hydride shift. The hydride will shift to this carbon. So what you are going to get here? The 2 methyls are there. There is a hydrogen. Because there is a bond, double bond between carbon and oxygen, you will get an aldehyde like this. And what is this? It's nothing but 2-methyl propanal. Therefore, the correct option is option A. Students, the last part is a little bit tricky here because many students will get confused whether dehydration will happen to this primary alcohol or tertiary alcohol. Just remember that the tertiary alcohols are more reactive than secondary than primary. Therefore, this will undergo dehydration first to form the tertiary carbocation. This is a driving force here. And also, the hydride shift is more preferred than the methyl shift. If the dehydration would have happened here, then methyl shift should happen, which is difficult in this case. That is the reason you are going to get the desired aldehyde over here. I hope I made the concepts clear to you, and if you have any doubt you can ask them in the comment section. And if you think I have missed out any important topic from hydrocarbons, you can ask your doubts in the community as well. Thank you for watching this video and don't forget to subscribe the channel.